Hello, class. Welcome to today's class. We'll be looking at digital cartography by my humble self, Mary Liu Marcellinus, a cartographic lecturer. We are looking at digital cartography in today's class. Modern cartography is largely integrated with geographical information science and constitutes many theoretical and practical foundation of geographic information system. Modern cartography. The modern cartography of today integrates geographic information system into it. Gone are those days where maps were produced with the use of pen and ink on polyester or tracing paper or cut end strip. These days, geographic information has revolutionized the discipline of cartography, whereby digital method is being used to produce the map. So what is digital mapping? Digital mapping is all about processing or collecting the data, you compile the data and you format it into a virtual image. You collect the data, you compile it, then you format it into virtual image. That is digital mapping. You source for your data from any sources of it. You compile the data. You could sort for for point feature, maybe from Office of Survey General or from Ministry of Land and Survey. You could source for your data from the Google imagery. You could source for data from the OpenStreetMap. When you gather all these data from different sources, you now compile it into one, then you format it and you have virtual image. So digital mapping, or you may say digital cartography, is all about collecting data, compiling it, and you format it into virtual image. Is that understood? Now, sources of data for digital cartography. One of it is the satellite imagery. Satellite imagery is one of the sources of data for digital cartography. You can get data from satellite imagery, the image, that is the satellite that orbits the Earth. As it orbits the Earth, the image or imagery of the Earth's surface is being captured. Then it is analyzed, then you compile it and get it, use it for what it is meant for. Another sources of it is aerial photograph, where aircraft is being flew over a particular area, and as it flies around or as it flew, it captured the data, and there must be an overlap on each photograph so that important information will not be lost out. So aerial photograph is another sources of data for digital cartography. The next is geographic global positioning system. The global positioning system is what all know, the handheld GPS, where you go out with it and collect a precise location of a feature, which will be in coordinate form. Next is the geospatial database, or you may say geospatial bank, where all the data maybe point feature, line feature, polygon, metadata and the likes are being stored or being kept for usage or for future usage. Next on it is the open data. Many organizations have this. Many organizations, many government of or parastatal or communities or a group of communities that have a specific interest for something have this open data where you can sort for data for your digital mapping. We also have the survey and field data, whereby you go out with your equipment or with your gadget, you take the measurement of the feature, you observe it and you record the data. Next, we have the crowdsourced data. The crowdsourced data in this is the data that have been contributed by different people into a particular let me say like platform, whereby it it is made readily available for the public. A good example of it is the OpenStreetMap. OpenStreetMap is the crowdsourced data made available for all. So you can sort for data for your digital mapping through crowdsourced or crowdsourced data, open data, field and survey data, imagery, area photograph, geospatial data base or basis. The next we are looking at is information that emanates from the above sources of data I mentioned earlier. For area photograph, you have high resolution imagery for area photograph. That is the sources of data for digital cartography. The data you obtain from that source is high resolution imagery. Another is the satellite imagery. You have image or imagery of the earth. It could be in small scale, large scale, or medium scale, depending on what your interest lies on. Next is the GPS, the Global Positioning System. This gives you a precise geographical coordinate. You need a coordinate of a building with your handheld GPS, or even with your phone, you get the coordinate of that building, coordinate of a tree, coordinate of a school, coordinate of a borehole, coordinate of anything. Just set it, wait for the accuracy to have a better accuracy, then you capture the data. Next on it is the geospatial database. What kind of data that emanate from this? Different data, that is a detailed information data, maybe information about a data which is called metadata. So we can get that from geospatial database. Next is what kind of information emanate from open data? Is a diverse data set diverse data set that covers various aspects of geography. So that's the type of data you can get from open data for your digital cartography. Next is survey and field data. Measurement of the feature. That is the type of data you get from that. Measurement of the feature, the length and breadth, the coordinates, the height. So those are the type of data that emanate from field field survey. Then next is the crowd sourced data. Crowd sourced data. I've mentioned it earlier. The OpenStreetMap is one of the crowd sourced data where the data is readily available. If you're conversant with QGIS, if you can obtain this type of data or this OpenStreetMap data via QGIS, all what you need to do, you launch your QGIS, you go to the plugin. From the plugin, you search for HCM, you add it to your plugin. From that, you obtain OpenStreetMap data. Next on this is the user contributed information, often collected through mobile application or participatory mapping activities. Good example is the missing map. That is good example of participatory mapping activity. Missing map. Then using of mobile data to collect, you can use Kobo Collect, which is Kobo Toolbox. You sign up, then you get the data collected via the app. Thank you for listening.